It's interesting hearing about people's work in science here. I actually did science fair in middle school as well, and then through high school, and yeah, so keep on, to all the students here, keep on doing that stuff because then you'll end up cool places. I'm going to tell you about geology stuff because I think that's the coolest, and you probably don't hear about it in high school. And so, we can go ahead and jump into the presentation here. I'm going to try to move this. All right. Sorry, can we go into presentation mode? Took us like an hour to get this set up. Apparently, PowerPoint 2017 does not play well with PowerPoint 2016. So, some of you kids should fix that. There we go. Excellent. Okay, so I'm here today to share with you 4 of my favorite things: space, the environment, Southern California, and we'll see how all these are related. So first of all, I'm going to tell you, you probably, well maybe you knew this, I'm from Michigan originally, I had to learn this ending up here, but Southern California is actually the space exploration capital of the world, and I'm not exaggerating when I say that, and hopefully I will be able to convince you to agree with me there. I don't know why we don't advertise this more. Then I will convince you that the space science that we do here has actually led the way to a lot of the environmental science and led to the environmental policies and everything that we know and love today that keeps us safe and keeps us alive. I don't know if you've seen the recent news, the recent study in The Lancet, that 1 in 6 people die in the world early because of too much pollution. And the US is actually one of the best countries for having reduced that. You all know that. Here we are in LA. We've done a great job cleaning up our air here. Then, of course, the thing that underpins all of this is STEM education. And so that's why we're all here tonight. And so I'll end with that note and how you guys can all get involved and experience some of the exciting things that I'm going to talk about. All right, so our story starts off in 1900s Los Angeles. And this is probably an unassuming hill that you don't recognize, but one day, 22 years from this picture, there will be a very auspicious sign that will show up there. This is what Hollywood looked like at the time. We're 12 years before the first Hollywood movie, and there's a young professor in Chicago who maybe you've heard of, George Ellery Hale, and he had just built the world's largest telescope. And so he's feeling pretty good about himself, but you know, to stay on top of your game in science, you've always got to be building the next big thing, the next awesome thing. So he's like, all right, I'm looking for a bigger telescope. But is anyone from the Midwest, like me? You know how cloudy it gets? Not a good place for a telescope. So he's on the hunt for somewhere that has better skies than Wisconsin does. So he's searching the US. And like many Midwesterners at the time, and I guess today, myself also, headed for sunnier pastures. And there's another special reason why he headed to Southern California that I'll tell you in a second. So then in 1908, he completed what now is the world's largest telescope, so he beat his own world record, 60 inches this time on top of Mount Wilson. How many folks have been to Mount Wilson? All right, you need to change that, guys. This is an awesome place. I'll tell you more about it in a second. So 1908, world's largest telescope went in at Mount Wilson. We're still 4 years before the first Hollywood movie. LA is just like a little blip on the map, and already we have the world's leading science institution here, funded by Andrew Carnegie. And it's crazy to think about, this is a picture of them dragging the telescope up the mountain. Like if you look out up at Mount Wilson and think before the tube was there, you had to take donkeys to get your extremely sensitive scientific equipment all the way to the top there.
Oh, okay.
But he did it, he got it all up there, and it's also crazy to think for a second. So when we say the size of a telescope, that's the size of the mirror. The bigger the mirror, the more light you can gather, and the more detail you can see with your telescope. And so a 60-inch telescope, just think how tall you are in inches. So something like this is the mirror on this telescope. And that even wasn't enough for this guy. He still wants bigger. So then 9 years later, he completes the 100-inch telescope, also on Mount Wilson. And you'll notice that's 100 years ago, and actually its birthday is coming up in a week and a half, November 1st. And so there's going to be some big celebrations up on Mount Wilson. You'll be able to look through these telescopes and that'll be held on November 4th. And I'll send this information to Ron and help you all to find it. But just remember, Mount Wilson, 2 weeks from now, is going to be an excellent party. So that still wasn't big enough for this guy, 100 inches. That's like several of me. And so then he keeps going, and it's a little cut off here, but in 1949 he completed the 200-inch telescope at Mount Palomar, and it's finally okay for him, or maybe it was time for him to retire and he's not building telescopes anymore. But a lot of people don't know, Southern California had the world's largest telescope for 84 of the last, I can't do the math, since 1908, 109 years. 84 of the last 109 years, the world's largest telescope was right here in your backyard. And you can still tour these. We still have on top of Mount Wilson the world's highest resolution observatory. It's the Chandra Array. You can go up there and tour that too. This is all accessible right in your backyard. If you're one of the students here who's excited about to try some new science, maybe you want to go and find an astronomy mentor up there. They're phenomenal folks up there. So the reason that George Hale wanted Mount Wilson is actually the same reason that we have such horrible, or part of the reason why we have such smog here in LA today, which is the inversion layer, which maybe you've heard of. But this picture is a little dark. We're going to use our old-fashioned laser pointer here. And so it'll get lighter. This is going to be a time lapse here. We've got the observatory in the front. And then you'll see that there's a bank of clouds here. And the inversion layer is a lid that just sits on the clouds and the smog and doesn't let them get up. So that's a problem with the smog because we're in a little fishbowl here, the LA basin, with the lid on top, and the pollution from our cars can't get out. But it's awesome for looking through telescopes because it can't get up and block the views on the telescopes, and it's not cloudy. So I'll just go ahead and play this time lapse. Unfortunately, Mount Wilson is always in risk of getting on fire, as with so many things here in Southern California. So this is a time lapse of one of the recent fires. It actually, just Wednesday of this past week, a fire broke out there, literally just underneath the telescope. And if you go out tomorrow and look up at the mountain, you'll see the red fire retardant that the airplanes have dumped all over it. So anyways, the point here was to look at this lid, keeping the smog and the clouds underneath the observatory. This is a great place for a telescope. And so, if we're going to talk about environmentalism, what do we do with old telescopes? Do we just throw them away? We've got our reduce, reuse, recycle that we're supposed to follow. We're not going to reduce our telescope use. That's not very good for astronomy. So then, what are we going to do with these? And so we can go visit them. The Mount Wilson telescopes are basically museums now. There's a bunch of curators up there. They throw special events. I went to a series of concerts up there this summer. It's a great musical space also. You can go look through, you can actually even rent the telescopes just for your own self if you want to go and spend all night looking through what used to be the world's largest telescope. You can do that. And then, as I said, the 100th birthday bash is going to be on November 4th, and I will be there. I hope to see you there. Now, another thing, so now getting into part 2 of the talk, the relationship between space and the environment. And so one of the things that we do with these old telescopes is we actually turn them, rather than looking up to the stars, we use them to look down and study Earth. And so this particular observatory is near and dear to my heart. That's where my office is. For those of you who can't see, a picture of my face just popped up in there, but this is from 1920. We don't drive these cars anymore. And so what they basically do, and you already kind of know this, is that you can tell what type of pollution is in the air, what is in the air by what colors are in the air. And so, just like the simplest terms, this is how I need to understand it too, is if it's bluish, who's been hiking in like the Smoky Mountains or anywhere where there's like lots of fog everywhere? Wow, okay, not many. You guys really like California. All right, well, places that have more trees, the trees actually release a lot of organic molecules, and this is how they kind of communicate is the wrong word, but that's how like fruits ripen and everything. It's these molecules being released. Those have a bluish tint. Here in LA, we're more used to the yellowish tint. and those come from nitrogen oxides, which are a specific, they come from cars, and then the sun shines on them and they turn into even worse things. And so you can see yellowish tint here. And then obviously we all know from forest fires, black soot, and then the fire itself. And so what if we had more than just the three colors, blue, yellow, and red? We can go with Crayola colors, or we can go and use every color of the rainbow. And in science, we're going to use every instrument that we can, as detailed as we can, and get down to all the different frequencies of light, down to hundreds of different, lots of frequencies. And so actually, this technique came from astronomy. You're probably familiar with many of these great Hubble pictures. And these same pictures actually, it's the same thing as these telescopes are doing when we're trying to figure out what's in the pollution in LA here. And the different colors of, these are giant pillars of dust and gas. It's the same thing, you can use the colors to tell. And these colors are actually different than the ones in LA. So here we've got green representing hydrogen. So just looking at this map, you can tell where all the hydrogen is. Red, you can tell where the sulfur is. And blue, you can tell where the oxygen is. And so it's the techniques that we developed to look at the stars and returning them to our own planet and using it to better understand what we're doing to it. So this was such a good idea. So this telescope, here in Pasadena at Caltech, where I am, it's been duplicated all over the world. There's like 20 different telescopes that do exactly the same thing. But what if we could get even more than that? What if we had global coverage at very high resolution? So to do that, we have to go up to look down. And so we start launching satellites. And this is a launch from actually just up the road at Vandenberg Air Force Base in Santa Barbara. And you can go there and watch launches. And so this particular satellite is called the Orbiting Carbon Observatory. And what it does is it's the same idea. It looks down at the colors and figures out how much carbon dioxide, carbon monoxide, and other things there are. And so from that, we can actually put together movies of those carbon dioxide plumes moving across the surface of the Earth. And so red in this animation is high amounts of CO2. You'll see it coming out of heavily industrialized areas. So the east coast of the US, Europe, China. And another point here is that everything's connected. So those high polluting areas, someone's going to be downwind of that. And so we have to look for solutions beyond just looking at our own power plants. We have to work with our neighbors and figure out how to get them to clean up their act so we're not breathing their dirty air. So, the idea of looking at things from space is pretty neat. What else can we figure out from there? So we can go to space if we want global coverage. Another reason to go to space is things that are hard to measure from the surface of the Earth. So one of these, and a very relevant one here in California, is groundwater depletion. And this is kind of an iconic image. I'll describe it because it's kind of low resolution here. There's a telephone pole. This is in the Central Valley, the guy standing here for scale. And what's written are years. And this is where the surface of the Earth used to be in 1925, 1955, 1977. Because so much groundwater was pumped out that the surface of the Earth actually went down by a whole telephone pole's worth in half century there. And same thing's happening all over California, all over the US, all over the world even. And again, here's a more recent picture, 1965 to 2013. And this has implications, like it causes huge cracks in the ground. This particular crack is from Edwards Air Force Base, and this one actually caused the shuttle, delayed one of the shuttle missions to land because this crack runs right through the middle of the shuttle runway. It's also going to affect our aqueducts that bring our water to Los Angeles. So this subsidence from overpumping of groundwater is really, it's going to cause some serious damage, and it's really hard to measure. So some really smart folks up at NASA figured out this awesome satellite called GRACE. Space must be a SoCal thing because they really love the abbreviations and all these things. So GRACE stands for the Gravity Recovery and Climate Experiment. And it's a set of twin satellites that orbit the Earth. And everything that has mass has gravity. And so if there's a little bit more mass in this part of the Earth, it'll tug on one of the satellites, and they're shooting lasers back and forth at each other, and so they're able to tell if one of them moves a little bit because it got pulled on by something. So this here is a map of the Earth that is mapping the amount of gravity. So here the red bits have extra gravity, there's extra mass there, and blue has less mass. And so it turns out you can use that to map groundwater depletion, because water is matter, and it has mass, and it has gravity. And so we actually are able to generate maps of the US that measure the drought at every place in the US at once. Here's an animation of it, where red points are in drought, and blue points are have extra water. And we're going through, these are each time step is a day, so we're moving through years here. And this satellite was so successful, they're going to build another one that's even going to be better resolution, which is going to be, it's just crazy to use gravity to detect water. It just blows my mind. All right, so another thing that we can do is access areas that are hard to get to on foot. And so the California example here is measuring the snowpack up in the Sierras that is going to be our water. And so that will help us predict droughts that are coming up. And so this is another iconic picture. This guy here, Frank Gerke, is California's chief snow surveyor. It's kind of an awesome job title. He's there with our governor. And they're in a part of the Sierras, this was last January, part of the Sierras that's supposed to be covered in snow. Oh, no, this is 2 Januaries ago. Last January we did have a decent amount of snowfall. And so his job is he goes around with a stick and pokes it into the snow and sees how deep the snow is, which is pretty inefficient. I don't know if you've been hiking in the Sierras, but it takes a while to get around. And so again, NASA stepped in and they were like, hey, we have a solution for you. And it's still in the testing phase, so we test things on airplanes before we ever send them up on space missions, on satellites. And so this is the Airborne Snow Observatory, and again, it's going to use lasers, and it's going to fly over the Sierras and shoot lasers down and see how long it takes the laser light to return, and then be able to make a map of the elevation of before the snow falls. And it's hard to see, but there are 3 points where Mr. Gerke surveyed, and then here's the map generated by that airplane in a fraction of the time. It just flies over and measures the whole thing. So this is the future of our drought prediction, and you'll be reading about this in the newspaper probably every January from here on out. So keep an eye for Frank Gerke. All right, so there's something else really exciting that all those missions that I just mentioned, they all have something in common. They were all built right here, JPL in Pasadena, Southern California. These are all, yeah, all right, there we go. So we are here in SoCal, we are leading the way on these environmental science space missions. These missions to planet Earth, basically, doing exploration that no one's ever done before. And perhaps you know JPL a little bit better. This is a map of Mars, so I'm actually a Mars geologist. This is what I spend my time looking at. And I've indicated here all the missions that have gone to Mars, and there's a whole bunch. There's 13 up here. 6 of them, these red X's, crash landed, and the remaining 7 successful ones, and then there's 1 additional one. The 7 successful ones all were done by JPL. So JPL has done more missions successfully than the entire rest of the world has even tried. They're 0 for 6, we've got 7. Like, we're doing great. Between those 7 missions, we've spent 37 years on the surface of Mars. So it's been, and this has been led from right here in your backyard. Again, I don't know why this is something I didn't learn about in Michigan. Like, tell everyone if they don't live in LA. And so probably most famously though, right now is the Curiosity rover, the selfie-loving rover. It's probably a millennial. And I'll let you in on a little secret that they didn't tell anyone until after they launched the rover, which is its wheels, I'm going to zoom in on the wheels here, have this funny pattern of holes in them, which you might think is not very good for driving a rover. You want like as strong wheels as possible. So those of you who are into secret codes, it actually turns out that this spells JPL in Morse code. So NASA said, no, you can't write your name on the rover. And the engineers at JPL were like, we're going to write our name on the rover. And not only that, we're going to put it in a place that we're going to stamp our name into Mars. I mean, they're leaving tracks anyways, so might as well leave your name behind. So next time you see these pictures, just like laugh to yourself. All right, so for those of you excited about Mars like I am, in 2020 there's going to be a new space race. There's 5 countries that have announced plans to send missions to Mars. And obviously, the American one is coming from JPL again. But then there's going to be 4 other missions, and it's fun to be a little competitive, but we're all scientists, we want everyone's data, so we want all of these missions to succeed. And it'll be so cool to just be getting pictures after pictures every single day from 5 different missions on the surface of Mars. It's going to be so great. But before that, there's actually another mission in 2018 coming right up. It's going to launch in May 2018 by, again, you guessed it, JPL. And this is probably the most Southern California mission ever because its job is to measure earthquakes, Marsquakes, I guess, to figure out the interior of Mars. We don't know anything about the interior. And that'll actually be launching, again, from Vandenberg, right up the street here, and you can go visit it. So here we are in LA, and that's where we want to be in Santa Barbara. It's hour-and-a-half drive, and it's a lot of view spaces open to the public, so anyone can go watch these launches. A Mars launch is going to be a huge rocket. It's going to be crazy, so I highly recommend blocking off May 2018 for that. All right. So actually, another thing that's awesome about Vandenberg is, so turning back to Earth science again, is that the launch site, you'll notice it due south of it, or it's surrounded by ocean. And so actually it's a great place to launch all the Earth observing missions. Everyone knows Florida, because that's where the astronauts go. Because in order to get to the space station, you have to fly east. In order to look at Earth, you actually have to fly south. So all the Earth missions launch from Vandenberg. So this is like the hub of environmental space science. Right here in our backyard. And so I'm going to show a couple of my favorite Earth missions, Earth exploration missions. So this is the GOES satellite. You're probably familiar with it if you've ever watched the Weather Channel. A lot of people think the Weather Channel is like just generating all this data itself. No, if you watch the Weather Channel, that's coming from these satellites that we've launched. So we're not just tracking carbon dioxide, we're not just tracking snow cover, we're tracking where are hurricanes. And so I have kind of a personal story with this one. We were out studying the effects of Hurricane Irma. We were down here in the Turks and Caicos, and sitting in a hotel room, Maria moved a bit faster than we were expecting, and so our flights got grounded. And so we're just sitting in the hotel room refreshing this image, like watching Maria come closer and closer. And so like this data is actually, this is what you can use when you're watching these disasters come on, just stare at them and go, oh no. But I like to think of these satellites as webcams for the Earth, basically. So this is one of them. We're getting like real live feed pictures from these satellites. Here's another of my favorite ones. This is called Discover, except they've left out a bunch of the letters, and the name of the camera is Epic, which, I guess that means it's going to take great pictures, which is good. So, how many of you went and saw the eclipse? Yeah, all right, excellent. So this is actually a photo of the Earth while the eclipse is happening. So you are all in this picture. This dark spot moving across North America is the eclipse. And so right as soon as totality was over, I ran back and tried to pull up this picture so I could look down at where I had just been looking up, which is kind of a cool feeling. And this data is all online. You guys can do it yourself. I highly encourage you to. So that's another webcam. And then another one that has better resolution. You can actually zoom in on things. I wanted to pull this up in real time because the data, literally the satellite sends it down to NASA and they put it up on this website. And so you'll recognize California here, outlined, Central Valley. And I pulled this from last week because this is actually showing all those forest fires that we heard about. So we can use this to track other disasters. So all these are not clouds. These are plumes of smoke from the Santa Rosa forest fires that are basically the size of California. And there's not just one, you see them burning all over the state. And so this, you can, I was watching the fires in real time from space. And you can do the same thing. They have a bunch of other data as well that you can pull up. This one is just called Worldview, another easy one to remember. All right. So if we've got our webcams, which are telling us what the Earth is doing right now, my other favorite mission is the Landsat mission. And this basically is the family photo album. We have photos going back to the 1970s. It flies, we're on the 8th Landsat satellite now. and we can use it to monitor changes across the Earth's surface at the decade scale. And this is actually an amazing project. Google has made it very easy. They put all the images together into movies that you can just like Google Earth, except it's a time lapse. And so you scroll around Google Earth and you can look at all these different places. So right here we're looking at Las Vegas, starting in 1984 going to 2016, and we're watching it grow. And as it grows, Lake Mead is shrinking, which is a problem because that's where all their water comes from. That's where our water comes from also, one of the many places. So we're just watching cities grow and reservoirs shrink here. You can also watch forests get torn apart. Here is in Brazil, Rondônia, another place I've done field work. And this data actually is used by the UN. There's a program where they incentivize countries to not cut down their own forests because it actually turns out it's bad for your country if you cut down your forest. You wipe away all the soil and cause lots of other damage as well. And so they use this Landsat data to help check on these various different countries. So you can get deforestation. We have it in Canada as well. This is strip mining for the tar sands in Alberta. You can just watch the scale of these mines grow and grow and grow. And then another one, so we can go from the tropics all the way up to the poles. Here we are in Alaska with the Columbia Glacier rapidly shrinking back several tens of miles in just a few tens of years. And so these missions are really helping us to understand Earth in a way that we haven't understood before. And this all comes back to STEM. And so one of the things that I really want to highlight here is everything that I just showed you is associated with a research institution here in Southern California. There's so much science going on here. There's so much space science, environmental science, all the other ones that I think much less about. For some reason, this is not something else that we don't talk about, is the quality of education that we have in Southern California is really, just really rich. And so I want to come back to that photo I showed you at the beginning, Earthrise, that you're probably all familiar with. And this photo to me sums up everything that I'm trying to tell you here. So this actually was hailed by Time magazine as it's one of the 100 most important photos of all time. And it was seen as kicking off the environmental movement in 1968